Yeah. Uh, Good afternoon, all of you, my dear students. We have today our special guest, Mr. Saurabh Khanvilkar. Uh, he is actually working now as a senior engineering manager, storage software, Seagate Technology, Pune. So, first of all, I would like to say a few things. Uh, few things. Few things about Saurabh Khanvilkar. Um, that is kind of his introduction. uh, Saurabh and myself, we started our journey from uh, from 1997. We started our journey with our diploma from Vartak College, Vasai. After that, we got admission in VZTI, and we did our BE in 2000. And after that, he joined the few companies, like he joined Wipro company, and after that he joined another company, and now um, more than 6 to 7 years he has been working in Seagate company. Now the special thing is about him that he has got a 7 US patent. Right? As if you go through the LinkedIn profile of Mr. Saurabh Khanvilkar, then you will come to know he has published all these 7 patents, and these are publicly available. So kindly, he has around 20 years of industry experience in software, especially 12 years in storage, firmware, and software. So I would like to first of all congratulate Mr. Saurabh Khanvilkar that he did a lot of improvement, I can say, or he reached at that level, so that now everybody in the world, they can call him as a special guest to deliver the lectures on storage management kinds of technology, which is very important one. Okay, so before starting our session, um, I request Insha Mullah from second year IT student to say a few words on the occasion of this Teachers' Day. Yes, Insha Mullah.
Good. Yes, sir. Thank you, sir. Good afternoon, everyone. As we all know, today is 5th September, which is celebrated as Teachers' Day. So, on behalf of all students, I would like to wish our teachers, our dignified teachers, Happy Teachers' Day. So, sir, you are here. So, on behalf of all students, you can take this wish. Thank you.
Thank you.
So, our students has supported us. Our teachers has supported us many times, and they have also taught us many crucial things. Even if I'll thank them 100 times, I won't be able to thank them for whatever all of them has done for us. So, but I would like to promise one thing, that one day we all will make you all teachers proud. Because according to me, best gift to any teacher is to see his or her students successful. Now, I would like to conclude by saying a small shairi written by me, which will express my feelings more clearly. आपसे ही है हमारी शान, आप ही है हमारा अभिमान। आपसे ही है हमारी शान, आप ही है हमारा अभिमान। क्या कहूँ मैं आप सबकी तारीफ में, अगर आप टीचर्स ना हो तो हम स्टूडेंट्स की कुछ नहीं है पहचान। थैंक यू।
Nice.
Very nice, Isha. Thank you very much. Um, so I now request Mr. Saurabh Khanvilkar to start his session.
All right.
Saurabh sir, uh, start.
Yeah. So Yogesh, am I audible? Am I audible? Fine. Audible
Yes,
and
yes,
visible. Fine. All right.
yes, yes.
Okay. All right. So thanks, Yogesh, for the nice introduction. Yogesh has said very nice words and big words about me, about the greatness and stuff. So I'm not sure if I am that great. I've been working in the industry for 20 years, and Yogesh came to me and said that he would like to have a webinar for his students from VSIT. And I thought it's a good idea because I've been working in the industry for 20 years, and I would love to share my experience of how the industry works and what are the latest trends in the industry, especially in the storage industry, because that is where I have spent most of my time. Okay, so let me start. Right. So today I'm going to talk about it's just an introduction to the storage technology. I know it's a digital platform and it is difficult to be interactive, but I hope feel free to ask questions in between. And I think Yogesh can pass it on to me, and it's okay to interrupt me, and let's make it as interactive as possible. All right. So the intended audience for this particular presentation is students doing their engineering and eager to start their careers in industry, or even go for their masters or research. I hope this will be useful for all the students. I think about me, Yogesh has covered a lot, so I'll just add to it. I passed my bachelor's of engineering in computer science from VJTI Mumbai in year 2000. Yogesh was my classmate. He was my classmate in diploma. He was my class, which we did from Vartak, Vasai, and he was my classmate even in the engineering. So after my engineering, I joined Wipro Technologies in Bangalore. I was there for about 4 years. Came back in Pune, where I am right now. After Wipro, I joined a small company called LSI. It That was my first step into the storage domain back in 2009. So there I worked in some technology called SAS. Um, let me talk about SAS a bit. Okay. So when we talk about storage, we have three main protocols that are the industry standard today. One is the SATA. I think most of you might be knowing SATA. It is the standard interface for connecting storage to your laptop or to your desktop. Okay, the drives that you get from market. So those are SATA drives. Similar to SATA, we have SAS. So SAS is serial attached SCSI. So it is an extension or an upgrade of the legacy SCSI protocol, which is probably one of the oldest standards for connecting any electronic device to a computer. So SCSI had its inherent limitations because of its parallel nature. It is a parallel interface. So that was converted to serial, and that's how serial attached SCSI was born. It is a dominant standard in industry today. And it is mainly used in the enterprise, in cloud storage, in the servers. So that is where it is mainly used. SCSI drives are more expensive because it is a higher bandwidth protocol. The drives are faster. Um, and it is more robust. There is a lot of error handling which is absent in the SATA protocol. So for all these reasons, general SAS devices are expensive. It's quite expensive actually, multiple 2 to 3 times more than the SATA hardware. So this is about SAS and SATA. So SAS is mainly where I worked for all these years. So I worked on SAS drives. I have worked on something called SAS expanders. I won't be talking a lot about SAS expanders, but SAS expanders is the area where I have got most of my patents, which Yogesh mentioned. So there is a third protocol called NVMe. Now, before I talk about NVMe, I should talk about SSDs or solid state drives. So I think most of you might have heard of solid state drives, or I'm sure everybody knows about pen drive. So a solid state drive is just a large pen drive. So when solid state drives became available, to general public, it became a feasible technology for making drives and selling in the market. So then, or just during that time, it was realized that the existing SATA and SAS protocols and the interfaces, they're not sufficient to take full advantage of the bandwidth of the SSDs. Okay, because SSDs are electronic devices. They don't have rotating parts. They don't have magnetic media. They don't have any mechanical parts like the HDDs have. That's why they are pretty robust, and also being electronic, they are very fast. The fastest persistent storage probably available today. So SAS and SATA, these technologies were not sufficient to cater to these SSDs, to take full advantage of these SSDs. So they thought that it should be interfaced to a different bus, and they started interfacing SSDs with the PCI, the standard PCI bus, and with that came the NVMe protocol. So just to take advantage of the speeds of SSD. So today we have SATA, which is one of the oldest protocols, SAS, and we have the fresh NVMe. So NVMe is still picking up. It has still not entered the market to a large extent. Today, the enterprise industry, the enterprise storage, is dominated by SAS. the client industry, the client in the sense the laptops and your desktops. Okay, that is dominated by SATA. And NVMe is also for enterprise. NVMe is coming also in the client side. A lot of the new laptops they're having NVMe drives, so it is picking up. So this is about what interfaces that we have currently in the market. So today we are going to talk about the evolution of persistent storage, a look at storage capacity. I'll talk about data explosion, how much data is there today and how much data is getting created, how much data is getting saved. So I will take a brief look at that. We'll talk about the big buzzword, right? Cloud storage. So I'll talk a bit about cloud. I'll try to explain from my perspective what cloud means. And then the last two topics are about the industry, embedded system software development, what kind of skills are required to work in the industry, in the storage industry. So I'll just talk about some opportunities that are there in the storage industry and how big is the opportunity. I'll touch upon that. And in the end, I'll talk about a software development process. Okay, I'll touch upon some latest trends in the industry, how the software development process is these days. And again, feel free to interrupt me for any questions. Okay, so Yogesh, if you get any questions, feel free to interrupt, and I'll try to answer. All right. So persistent storage. So persistent means the data is there. Data is available even when there is no power, even when the device is passive. So that is the definition of persistent storage. So for example, even our RAM, right? RAM is also storage, but it is not persistent because once there is no power, there is no electricity, the data goes away. The data is not stored. So RAM is the fastest storage device that is available today, but it is unfortunately it is not persistent. So it started with punched cards. I think punched cards came somewhere in between 1940 and 1950, if I'm not wrong. I think IBM was the pioneer in the use of punched cards. So this is basically paper and some holes punched in paper, and machines which could interpret these holes in the paper and make sense out of it. And this is how data was stored in those years. Then came the magnetic storage, floppy drives and hard drives, which is still there. So today we don't have floppies, but hard drives are the main storage that is available today. Then came optical storage, CD drives, DVDs, Blu-ray discs, right? So a lot of these drives are used in media, movies, and audio, right? So and also for backups. But in the storage world, in the enterprise storage industry, it is still the hard drives which dominate. Then came flash storage. So I touched upon flash storage a little bit earlier when I was talking about NVMe protocol. So this is basically purely electronic, lightweight device because it has no mechanical parts or no magnetic things. So just for an example, right? If you have a laptop which is on hard drive, if you drop the laptop, there is a very high chance that the head of the drive, the hard drive in the laptop, it'll crash the media and your hard drive will be damaged. But that does not happen with flash storage because it has no mechanical parts. It is a pure electronic storage. So there is a nice photo of a flash drive here. It could be probably an 18 TB drive. Okay, in such a small form factor. Now we also have flash storage in our mobiles. All the storage in mobiles, right? The flash cards, or I don't remember what it is called, SanDisk cards or something. So
Hello, Saurabh.
yeah.
Sorry to disturb you. Have you shared your slides?
Okay, it's
Actually,
not.
yeah. Actually, you have not shared that.
All right, just 1 second. Thanks for letting me know.
No, because you are saying, na, just see the flash card, very nice photo. That's why
Yeah.
I just thought that.
Yes, I was actually. Yeah, I think I forgot to share.
Yeah. Okay, 1 second. Yeah.
All right, it is visible now.
Yes. Visible. Continue, Saurabh.
Okay. All right. So I also mentioned about a picture of the punch card. I think so. Yeah. So it's on the right hand side of the slide. So Yogesh, it is visible fine now, right?
Yes, continue,
Yogesh.
continue. Yeah, yeah.
All right. Okay. Yeah. So yeah. So flash storage. So that is the latest the new technology, and today we still have hard drives. That is still the main storage in the enterprise domain because of the cost. Flash storage is very expensive today, but still it is picking up, and a lot of the server farms, right, the storage farms, the cloud storage. So the flash drives are picking up in that uh, those racks. So what's the future? Okay, so there is a lot of research going on in something called DNA storage. So when I say DNA, it is the actual DNA strands, okay, which form humans and animals, right? So someone discovered that we can actually store data in DNA. So how much data we can store in a DNA? We can store about 200, more than 200 petabytes of data in 1 gram of DNA. All right. So 200 one petabyte is 1,000 terabytes. Okay. So you can imagine that 200 plus petabytes of data in 1 gram of DNA. So how lightweight that those drives can be, and how much data they can store, right? If you see the flash drive photo here, if you have a DNA storage drive of that size, you can imagine how much data it can store in that small amount of space. So DNS storage has another advantage. It is very durable. Just to compare, okay, take a hard drive, write some data in that, and keep the drive in some cupboard or in some nice cool place for 10 years. Now take the drive back after 10 years and try to access your data. There is a very high chance that the data is lost. That is because flash drives and hard drives, they're not that durable. Okay, the standard life that any company gives, it's 5 years, and that too when the disk is in constant use. At least it is powered up sometimes. It is not always off. So then the durability or the warranty is about 5 years. DNA storage, you can store data for hundreds of years. It'll just store the data, keep it somewhere in a reasonably cold place. For hundreds of years, the data will still be there. So that is the potential of DNA storage. It is in a very nascent research phase. It is still not. It's still not practical. It is still not practically available. It is very expensive, and there is one big problem with storage, apart from the cost, that the writing data in the DNA storage and reading data from there, it is extremely slow. So that makes it very impractical to actually use the DNA storage. But hopefully in coming years, maybe next 10 years or 20 years, we will see a lot there. All right. Okay, so just to give a perspective, the left hand side or the big picture, right? I'm not sure whether you are seeing to your left or to your right. The big picture is there is a huge, big cupboard-like thing, right, being shipped from a plane. So that is IBM's first hard drive. Okay, in 1956, its capacity is 5 MB. Okay, just 5 MB of capacity. Now today, our small pen drives, they are like 16 GB and 32 GB. So that was in 1956. Fast forward to 2020. On the right hand side, you see two images, one of a hard drive, one of a solid state drive, SSD. So these capacities are like in the range of 18 TB. So today the hard drives that are available, which you can easily hold in your hand, very lightweight stuff. So they are of 18 TB capacity. So you can see for in the past 50, 60 years how much change that has been, and you can imagine with things like DNA storage coming up, how this same slide, if I'm presenting probably 20 years from now, it'll look so different. All right, I think about storage capacity, this is something which everyone, even I think the kids know these days about capacity, but I'll just quickly run through. We have bit, which is the basic unit of storage. It is just on and off, 0 and 1. And we have byte, which is 8 bits, kilobyte, which is 124 bytes, then megabyte, gigabyte, terabyte, petabyte, exabyte, zettabyte, and yottabyte. So these are the definitions for capacity, storage capacity that we have today. Just to put things in perspective, 5 exabytes of data, okay, that can store all the words in all languages ever spoken by humans since the start of mankind. Okay, so that is how much space, that is how much storage 5 exabytes is. And just earlier I mentioned about DNA storage, which can store 200 petabytes in 1 gram of in 1 gram of DNA. So you can imagine how much data can be stored. Let's come to one interesting, slightly interesting thing. When we talk about capacity, there are two standards for defining capacity. One is called the binary standard, and second is the decimal standard. So in binary, we have a multiple of 1024, and in decimal, we have a multiple of 1000. So storage industry standard is to display capacity in decimal. So this is something interesting to note. So let's say you go to the market and buy a 1 TB hard drive. So the capacity that you get is not 1 into 1024 into 1024. It is 1 into 1000 into 1000 into 1000 into 1000. So that is the capacity that you get. So always remember that the storage industry standard, when you say capacity, it is a multiple of 1000 and it is not a multiple of 1024. Data explosion. Okay, what are we looking at? Where are we going? So these are some interesting predictions which are done by some data research companies, which I have just pulled from the net. So these are the predictions for 2025. The predictions are 70% of the world population will be connected to the internet. You can imagine internet reaching the nooks and corners of the remote places in the world. 70% is a huge percentage. So all these people will be connected to the internet, and they will generate data. Every person will have about, on an average, 4 connected devices, or 4 embedded devices, or 4 connected devices with him, all generating data. So even today we have about three. I think every person has a laptop, he has a phone, he has a smartwatch. Almost everyone has that. At least almost everyone has a mobile phone. So on an average, it will be 4 devices per person by 2025, all generating lots of data. 163 zettabytes of data is expected to be created every year in 2025, and it will grow. It will not come down. It will just keep growing from there. So you can imagine how much storage is required to store all this data, and that can give you a glimpse of the potential of storage industry as a career option for engineering, for work, as well as for research. Fields like artificial intelligence, they demand enormous amounts of data. So I'm sure some of you must be doing some work or doing some reading about artificial intelligence, and you might know that artificial intelligence is less about algorithms and more about data. Okay, to train your neural network, to train for your machine learning. Okay, you have the algorithms, but you need data. The more data you feed to the engine, the better trained it will be and the more accurate it will be. Okay, so artificial intelligence is a very data hungry, or machine learning is a very data hungry domain. Okay, so all this contributes to storage. So today, right, when we talk about hard drives, I mentioned that hard drive is today is the dominant storage medium. Okay, that is used, and there are only two companies in the whole world which make hard drive. One company is called Western Digital (WD), and the second company is Seagate. So just these two companies manufacture hard drives, which is used by the entire world. Okay, cloud storage. So I have put some funny picture here, which shows the evolution of persistent storage from punch card to floppies to optical to flash storage. And then we have this cloud. Everything goes into the cloud. So what is cloud? Cloud is nothing but remote storage, which you can access through a web browser. You need a simple laptop, you need good internet connectivity, and you need a web browser, and you can access the storage, which is remote. It is also referred to as software defined storage, because the actual storage is abstracted from you. When you get let's say 15 GB of free storage from Google, you don't know if it is hard drive, if it is a flash drive, it is a tape drive. You don't know what it is. It is abstracted from you, and so that is the essence of cloud storage. This remote storage, which you can access using your web browser and internet. There are four major players in the cloud storage who provide cloud storage: Google, Microsoft, Amazon, and Apple. So these are the four major players who have enormous amounts of storage, and they buy from companies like Seagate and WD. There are many other small players who are there, startups and other small players, but these four are the big ones. All right. So probably something that everyone, all the students here will be interested in, that what is all this has for them, right? What are the career opportunities? So this is from my personal experience. There are two main things in storage for working in storage industry. One is the embedded systems domain or the firmware, and second is the software domain or the cloud. So when you talk about embedded systems, we talked about flash drive. So you saw that small flash drive, right? So it is the main logic. It is controlled by something called a flash controller or SSD controller. It is one quarter the size of your thumb. There's a chip that's one quarter the size of your thumb. Typically, it has about 30 to 40 microprocessors inside that chip, plus additional hardware logic, additional hardware components or hardware blocks, which are necessary for the functioning of the whole drive. So that is the amount of gates or amount of transistors that are packed in such small size. And then we have the flash chips, and then the whole power thing, the interface, SAS or SATA interface, and the casing. So that forms the drive. So to run software, right, for all, I mentioned that there are about 30 to 40 processors that make the SoC or make the flash controller. So there is a lot of software that needs to run, that needs to be developed so that everything runs and you get the functionality of the drive. So all this software, okay, it is mainly developed in C, and I'm talking about flash drive, but this is true for any embedded software. Yogesh was telling me the other day that students these days they think that C is dead, that C has no value, and it is something to learn for one quarter or one semester and then forget. So let me assure you that that is not the case. C is the de facto dominant standard in the industry when it comes to embedded software. And there are a lot of companies in embedded software, a lot of embedded devices. I heard Yogesh does a lot of work in IoT. So IoT is mainly about embedded systems, and C dominates there, hands down. So I hope that helps. So other skill that you need is you need to be good in data structures. You need to be good in theoretical computer science. You should know CPU architectures very well, and a little bit of knowledge on electronics helps. So embedded system software is some career that can be thought of from engineering students from electronics and telecommunication and computer science or IT. So remember that it is more about computer science and less about electronics. The whole embedded system software business. All right. So coming to cloud storage. So cloud storage, we have you need to know about Unix systems and Linux systems. You need to be thorough about how these systems work, how to install them, how to deploy them in different configurations. You need to know about cloud storage technologies like Amazon AWS or Microsoft Azure, as an example. Virtualization software like VMware, file systems, monitoring and high availability systems. So monitoring and high availability. Okay, let me try to explain this a little bit. Uh, Talking about cloud, right? You have some storage provided by Google, and it is somewhere remote which you are accessing through your web browser. Now, let's say you take a photo and you save your photo there, and it gets saved in some hard disk which you don't see. That is why it is called software defined storage, because all these things are abstracted from you. Now, what happens, if wherever the storage is, there is some flood, and that the whole system where your drive was, that gets washed off. What happens? Does your photo get lost? It does not, because Google does not store, or any cloud providers, right? They don't store just one copy of your data. They store multiple copies. They store at least 3 copies of your data. That is required for availability. So if something happens, right, it's hardware, right? It can break. Things can happen. So if that happens, that your data should still be available, because that is what you are paying the cloud companies for reliability of your data. That is why they store copies and the data is still available. So that is a little bit about monitoring and availability. So there are some softwares and technologies which are focused for these things. So it is about monitoring and availability. Then of course web technologies you need to know, because as I said, right, all the access is through a web browser. So a lot of web technologies involved. C. C is also used in software defined storage. There is a lot of business logic. There's stuff like RAID. We have very short time here to talk anything about RAID, but it is basically redundancy, so that if there is some problem in the storage, your data is still accessible. So for such applications, for such software, C is still used heavily, even in the software cloud storage. Then you need to know Unix shell scripting and Python and Java. So this is basically the kind of skill set that you need to keep in mind if you want to work in storage industry and or the embedded industry. So on this slide, right, I have put a picture of the C programming language book. Okay, it is called the C Bible. It was written by Sir Brian Kernighan and Sir Dennis Ritchie, who are the inventors of the C language in Berkeley University in California many years back. So this is a I know when you talk about C, right? Most people read Yashwant Kanetkar's book, Latest C. Right? That is a very popular book, very nice book. I have read it myself. But this book, right, what the photo that I have put here, it's a very small, thin book, blue cover book, and it is extremely difficult to read. Okay, to understand one page of this book, you will probably need to read it 10 times. Okay, it is that power packed book. But I recommend that anyone who is interested or serious about embedded firmware, or after my talk, I hope I have motivated some people to focus on C, or to get acquainted with C. So I encourage everyone to go and read this book and give it a try and try to understand as much as you can. All right. So on the software development processes, we know, right, we have waterfall model, spiral model, V model. So these are the legacy processes that are still used, and which we learned in college and are in use. But the latest trend is something called agile. Now, I'm not sure if this is already part of the curriculum. Probably Yogesh can tell later whether agile model is something that is taught in the college curriculum right now. But this is the latest trend. So almost all companies, they are at least in the software domain or the firmware domain, they are going agile now. They're adopting the agile model. Now, again, agile is a very big topic. I encourage people to go and read on the net if you're interested to know about this, because this is something that is very latest, and all the industries are slowly and steadily adopting this. One interesting aspect about agile, I'll quickly cover here. Hopefully, it will make some sense. On the left hand side, I have a diagram. Sorry, it's very small. It's hardly visible, but I'll try to explain. There are two sections here. Okay, in one section you can see horizontal red lines, and in other section you can see a vertical blue lines. Okay, so let's talk about the horizontal red lines stuff. So there are three blocks. So they represent a project. So this project has some database. So that is the bottom cylinder. It has some business logic, and it has a UI, the top box, right? It's the user interface. So this is the project has all these things. Typically, project has these things, right? It has a storage, it has some logic, and it has a user interface. And let's say this is a 6 months project. Now, what happens? Okay, there are three teams: one for the database, one for the business logic, and one for the user interface. These three teams start on day zero, and they'll keep developing till the end, till all the features are developed. And at the end of the fifth month, they do come together and do integration and do testing, and then delivery. So that is the typical waterfall model. Now there is a problem in this model. The problem is that the requirements, right? The requirements they always change. They never remain the same. Okay, it is the nature of requirement to change. Now, waterfall model says that do feasibility study, do requirements analysis, then do design, then do implementation, right? It assumes that no, the requirements are not going to change, but that never happens. I won't even say almost never happens. That never happens. The requirements always change. So that is the problem. And when requirements change in this horizontal slicing model, right, in the waterfall model, what happens? Requirements change. This red line gets extended. Okay, and that's how projects get delayed. Now let's come to agile. Okay, the picture with the blue vertical lines. Okay, here we have something called vertical slicing. Now what we do here is divide the whole project in let's say 10 small projects. Okay, so one blue line, right? You can call it as you can look at it as a sub project, and then every 1 month or every 2 months you deliver that small project. Okay, everyone delivers that small project. So at the end of that 1 month or end of that 2 months, you have something working. Okay, you don't have the whole product working, but you have something working, right? It can be a demo system, or it can be a system which does some 10% of the work. Okay, so you have something that you can give to the customer, or if you're developing it for yourself, your own company, you can start using it. Now, does it? So do I mean that requirements don't change when you do a vertical slicing? No, requirements will always change. But what happens is, because it's a 1 month slice, right? A 1 month sub project or a 2 month sub project. At the end of the project, you always get a chance to look at the change requirements and change your plan for the next sub project or the next blocks of your project. So that is the advantage. You can always take a step back. Okay, replan your things for the next block and implement those things. So that is how you can cater to the changing requirements. So this is just one of the advantages of the agile model. But and I encourage everyone to go and read more about it. So because this is what is you started. This is starting to get used in the industry. All right. With that, I come to the end of my presentation, and no one asked questions in between. But now is your chance. If you have any questions, please let me know, and I'll try my best to answer.
Uh, yeah, Saurabh sir, thank you very much for giving the inputs.
Yeah,
Now
welcome.
there is one question uh, from our Anaga madam, Anaga Patil madam. So she is asking, kindly elaborate some example where RAID is used in real time.
All right. So RAID is used mainly in cloud storage. For example, I talked about Google, right? For you the storage is abstracted, and you just save your data and it goes to some Google storage. Now Google will implement RAID on their storage, right? Your data will be striped and saved such that if there is some failure on the storage, some hard drive fails, which unfortunately had your particular data, the data will be still recoverable because the cloud people, they would have implemented RAID on their servers. So you won't see RAID used in your laptops or in your home storage, right? That there we don't use RAID, but RAID is mainly used in the enterprise side. And we
Yeah,
also have excuse me, Yogesh, and we also have products, okay, called JBoards, or even Seagate has some products like that. So these are like boxes which have multiple drives in them. So even some of them have RAID.
yes. There is one more question from Insha Mullah. She is
Okay.
asking, can you please explain agile in simple language?
Okay. Yeah. Actually, what I explained, I thought it is simple, but looks like it is not. So, so okay. So I think agile is basically it's a model so that you can handle the changing requirements. Okay. As I mentioned, right? So the typical legacy model of working is to work in a horizontal slicing mode. Okay, agile is about vertical slicing. Break your project into smaller projects and deliver the smaller projects. And at the end of the small project, see if the requirements have changed and change your plan, and then accordingly plan your next smaller project. So I think that is the easiest that I can tell. But yeah, I think there is a lot of material on net. I would encourage you to go and check on the net.
Okay, actually, this question has been asked by one of the students. So
Okay.
she has picked it up. I think his roll number, I think 31. Okay, so thank you.
Okay, yeah, good. I mean, so my intention was, at least this word agile, it reaches people so that it garners some interest, and they go ahead and do the research. So good that has happened. So
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 next
Yogesh,
question, sir.
One question
Yeah,
for you. So is
yeah.
agile taught in the curriculum in colleges these days?
Uh,
Do you have agile methods in like subjects like SS,
yeah,
structural software analysis?
they, DevOps, this type of things are there in our IT syllabus now.
Okay, good.
Uh, yeah. So they have introduced that, obviously.
Okay.
Uh, yes. So there is one question from Tushar Mittal.
Hi, Tushar.
He's asking AWS or GPT, which is better to learn?
Okay, so Tushar, good question. I would like to clarify that my majority of my experience is in embedded firmware, and I'm very new to software, the storage software part. I know about Amazon AWS, but I don't have any idea about GPT, so I cannot answer about. I cannot compare answer based on the comparison between these two because I am just aware of one of them.
Yeah. Anagha madam just now clear that the agile model it will be covered in software engineering part.
Okay,
So
good.
it is there. Okay.
All right.
So now one question from Ayush Vishwakarma. What is read write cycle of storage device? So I think it's a
Um,
syllabus
yeah,
like question, but still.
Yeah, no, I'm not sure if it is a complete question because so Ayush, can you explain a bit more? What do you mean by read-write cycle? Do you mean time required to read and time required to write? What does it mean? I'm not sure. So if you can explain, I
So,
can probably, or you can if you can ask a more
yeah.
specific question, I can probably answer.
So I think Ayush, if you want to ask to elaborate that, please type in the chat box so that I can pick it up. Um, so in the meanwhile, Saurabh sir, I would like to ask you that a lot of kinds of things that students are learning, right? So many languages, platforms are there, right? And as you have given the basic thing that the C language, when the
Yes.
computer started, C language came, and when the computer will end, that's an infinite state. So it's the end of
Yeah,
the C.
I
So
don't know about the future. Yeah, but
yeah,
today it is dominant in the embedded industry. It is dominant. And Yogesh, it's strange. Okay, don't call me sir.
no, it's okay. But for it's okay.
All right.
Uh, but Saurabh, what happened? While learning the C language, it's there in second semester, and the many of the semesters, uh, uh, they are the students are learning different kinds of technologies. I think, and as I told you previously, that the students then forgot to continue with the C, and
Okay.
what are the challenges, what are the different kinds of projects. I think last time you just discussed about the project. So the same type of things, if you elaborate now, right? So what kind of projects they can do it, or if they want to do something like research work, after B, if they want to go for MS, and after that they want to do some their research work or like that, the step moving towards the thing where as you only did the kinds of patents and all these things. The patent is like the highest level in education where the people did their PhD, then after that they go for the patent like the things. But nowadays the trend has changed. So many students, they have got very new ideas in their mind, and with their new ideas they are trying to publish their papers in some journals, good journals, like in IEEE.org website, where everybody knows that it's a the researcher world. All the people, even we have also access the IEEE papers from IEEE websites, and we also started our research journey like that. So the same thing, if they want to do, go for the like research kind of things, by learning these things, simultaneously they will think on what they have to do further. So what are the basic steps they have to follow during their whole core engineering life? That is very important. So please elaborate on the some kinds of projects, what kind of projects they have to start with it, with these projects, how they will get confidence, and with the help of this confidence, how they will start their journey towards the research work, which is needed to the industry as well. Saurabh.
All right. Okay. Yeah, it is a long question. You covered actually a lot of topics starting from C and things for research and projects. Okay, so I don't think I'll be able to tell about any projects immediately, because it is difficult to immediately think about these things. But I can give some guidelines. Okay, to the students. So first guideline is, stick to the basics. There are a lot of things, as Yogesh mentioned, right? There are a lot of things, lot of new technologies, so many buzzwords, so many things are going on. Okay, but stick to the basics. Okay, what is important? Learn a good programming language like C or any programming language. If you're serious about firmware and embedded systems, you have to be good in C. Okay, you have to be good in maths. Okay, don't ignore mathematics is the core of engineering. It is always required, and it forms the basis of everything. It forms the basis of computer science. Okay, so don't ignore maths. Be good in maths. Okay, data structures and theoretical computer science. Okay, so be good in these four things. Okay, one programming language, mathematics, data structures, and theoretical computer science. So that will help. And this is on the study part. For research, and so Yogesh, you mentioned, right, that students have a lot of good ideas, right? So they already have the ideas. So what is needed is, after learning the language, after learning the data structures and TCS, theoretical computer science, okay, you need to apply. Okay, that is the key. Okay, don't just I know people are busy. 2 months you get for your studies, and then every 6 months, less than 6 months, there are exams, and in between there are exams. There are a lot of journals to write, papers and papers to write, and we have done that, right, Yogesh? And there is absolutely no time, but you have to find time. You have to put that extra effort, and you have to apply your knowledge. You create your own projects. You think about your own ideas and implement it. You don't just learn that C language to write your exams. Okay, you learn that C language to solve problems. Okay, you think about problems, think about good ideas, and you use these tools. Maths, C, all these are tools, right? You have to use these tools and apply them and make something with them. So that is the way to go. And that is how you should spend these 4 years, and then you have to get into some good college if you want to do masters or further PhD, or get into a good company. Okay, so wherever you go, right, you join a company or you join a good college. Both give you opportunities to learn. So even I would prefer, rather than formal education, I myself prefer hands-on. So I would join a company and do that. But it's a personal choice. But so you can go either ways. The main thing is to apply your knowledge.
Yeah. So I think and Ayush Vishwakarma the same question that he was asked. What is the read-write cycle of storage device? Now he is telling that something related to life or life of storage devices. So in that sense, he was asking, what is the read-write cycle of storage device?
Right.
So,
Okay.
Saurabh,
So yeah. So this question has answer based on context. So if you're talking, let's say, about solid state drives, okay. So every drive, right? Every drive has its own life. So it is. So what is the life that is typically published on the package of the drive? That how many drive? Let's say if it is a solid state drive, then how many drive writes it can withstand? Okay. How many times you can write it? How many times you can read it? So all those specs are there on the drive. It depends on the drive. It depends on the drive technology. It depends upon what kind of flash is used. So when I say flash, right, it is not flash is not just one thing. Okay, flash itself has different technologies. There is NOR flash, NAND flash. Again, different protocols of flash, different qualities of flash. Okay, so that there is also vast variance in that. Enterprise class flash, client class flash. So the question of this answer, it depends on what device, what manufacturer, what quality of drive that you're talking about. And that is typically when you buy a drive, it is mentioned on the drive. What is the durability of this drive? How many read-write cycles it can withstand?
okay, so I think lot of things that have been there related to C language. Like previously, we have discussed about some of the simple projects that after learning of a C language, like in let's say in the college, that you are given, to write a game in C or write a small game like in 2D or 3D. Then we have got something like uh, uh, compression technique. So compress the file using C language, All these kinds of things are very very important. And some of the part, you touch about this particular part with the IoT kind of technology. For example, that you have mentioned earlier, one of the simple project, so that we can have the LED indicator of a SCSI drive, right? So if the something function is going on inside the particular device, and in front of that, if we design something like LED indicator, right? So it will be very interesting part, which is much more required, like in storage companies. It's a small journey. If I can able to design like this LED indicators like stuff, and after that, how can we take it at the remote place? So it's a IoT stuff. So first of all, inside the embedded things, what happens? These things are lagging in syllabus. So Saurabh, can you just give the hint to start with it? How can I think on the study, or how can I think on the raid? How can I start with it? Because starting is very important. After you give a push, that you gave us the push that you start reading this particular book. Now this is much more difficult to understand, but if you try to grasp that, then it will be a very good things for all of us, right? Not only you start with the like letter C, so but you go like the basic things again. So like this, what I'm trying to ask you, please suggest us for the like LED indicator, like some of the projects, so that the students can able to start doing the task. Right? It's a hardware software combination. It's a firmware thing. So like this, please tell two or three some of the kind of projects where the students can able to start thinking on this direction. Saurabh.
Sure. Yeah. So I'll think about it and I'll get back to you on that because immediately I cannot think of a project and tell. So I told about that LED and interfacing an LED as a SCSI device, and enabling it using the SCSI protocol so that we can do some breaking patterns on that. So it's kind of a fun project. The intention of that project was it'll give a lot of knowledge on SCSI, on the SCSI protocol, and which is a dominant standard in the storage industry today, right? For interacting with hard drives and even for the flash drives. So and it is like a fun project to learn SCSI. So I would encourage start. So all these specs, right? The SATA spec, the SCSI spec. So all these are freely available on net. Okay, the whole industry standard specs are freely available on net. So I would encourage people to go and download those specs and read them. I think that is a good start. And about the projects, Yogesh, let me think about it. I'll get back to you on that.
Yeah. One more question from Tejas is asking: is SATA drive SSD or HDD type?
Okay, so Tejas, it's a very good question. SATA drive can be SSD or HDD. It can be anything. Okay, so these are two different things. Okay, SATA is the interface or the protocol, okay, or the language that you talk, with the media, with the storage, and SSD or HDD is the actual media on which your data is getting stored. So HDD or SSD both can be SATA, both can be SAS, both can be NVMe. So these are two different things, and anything can be connected to anything.
Okay. That Tushar Mittal is asking for comparison: how much life SSD has over HDD?
How much life SSD has over HDD? Okay, it's again a good question. I'll need to check on it. I don't have a ready answer for this. Um, See, if you go by the book, right, if you go by the cover, okay, when you buy an HDD or an SSD, I think both will come with a around 5 year warranty. So if you just go by that, right, it's very similar. But actually, I'm not sure if SSD has more life or HDD. Like I mentioned, right, you write some data in HDD and write some data in SSD, and keep them in a kind of cool place for 5 years and take them and see who has written data and who has more data loss. So that kind of data I don't have. I'm sure it will be available on the net, but right now I don't have that answer. But if you go by the book, all companies give a standard warranty of 5 years for both SSD and HDD.
Okay. So I think these are about the questions. Is there any more question from audience? Just 1 minute. We will wait for another question.
Yeah, sure. I hope this was helpful. No, my intention was to interact with students and just share my experience from the industry. I am myself from Varta College, and Yogesh came to me with this opportunity, and I thought it was a good idea to interact. This is the first time I'm doing this, by the way.
Yes, yes, yes. So I think I will now ask Isha. Are you there, Isha?
Yes, yes, sir. Yes, sir.
Yes. So I think uh, from student perspective perspective, please say a few words regarding this particular the lecture what we kept online lecture, and after that we will say the vote of thanks. So and
Yes, sir.
yeah,
So first of all, thank you for giving this session because it was very helpful. We got many informations from this. So first of all, I thank you. Now I would like to thank on behalf of VSET. So it is deemed to sorry. So it is deemed to a great. It is. I'm very sorry. It is a great honor for me to purpose this vote of thanks. So, on behalf of VSET, I would like to thank all who have helped us in making this seminar a success. First of all and foremost, I would like to thank Mr. Saurabh Khanvilkar sir for giving this session by gracing it. And then I would like to thank our principal, Mr. Harish Vankudre sir, and our HOD, Mr. Ashish Vanmali sir, for giving us an opportunity to conduct this seminar and also for their moral support. I would also like to owe special gratitude to Yogesh Pingle sir, who gave his valuable contribution by conducting this seminar and by organizing it. Thank you very much, sir. And lastly, I would like to thank our viewers for bearing their ears to this seminar. Thank you.
thank you, Insha.
Yes, sir.
Yeah, thank you from my side. Thank you for your time, and thank you for listening to me. I hope it was not very boring.
Yeah. So just 1 minute, we will wait if there are some questions. But the comments are very good, sir. That Anaga Patel madam is saying that it was very nice session. Actually, she is the staff who is teaching, the storage management systems, this kind of subject in our college, and she's saying that it was very nice session, and obviously this type of sessions that we are going to keep it again and again, um, because a lot of students they want to learn this kind of technology. Now today I think you deliver about uh, what are the different kinds of trends there in storage domain, software domain, how the students can how the student should start their journey. But now I would like to say that even after in future or in future, we will just not only give them the just the idea, but I think I will request you that if you have got some time in let's say Saturday, Sunday, or whenever you feel, you just give me a call, and we can keep a lecture, and start taking a session in detail. That is, we will start actually learning the technology from you, because whatever we are lagging in our syllabus or in academia, we have to overcome that, and our students should get placed in very good companies like in Seagate company, because a lot of opportunities are there in embedded, and many kinds of things are happening in the world. So I think not only because while learning or while making a journey from semester 1 to semester 8, the students are doing are learning lot of technologies. Actually it was not there in our lifetime. We had only a few languages or few stuff like that. We stick with that, and this is what the output of like you that you reach at that place, at this place now. And obviously we are going to keep one more session of you in future, how to go for a patent, because that patenting is very very important. Even from a small point, small thing to a large thing. The student, how the students can able to think themselves to go for a patent. So that is a need, right? Once I will reach in industry and after that I will go for a patent, that's a different kinds of story altogether, because you are now in industry. But right from as a student journey, right, then if they want to think about it, then obviously it is going to helpful for them in future. So again I thank you very much. Again, many comments are there. Vidyashi Rao is saying very nice session, sir. uh, so thank you very much. Divya Chaudhary is saying thank you, sir, for a great session. Okay, so
Oh, thank you all.
thank you very much, sir. Okay,
All right. So that's it. The call is getting ended.
yeah. So
All right.
I'm ending now broadcasting, sir. Okay,
Sure.
1 second.
Okay. Thank you all. Bye.